All right, I'll be talking today about about getting started with open science. It's kind of an introduction to some of the concepts if you're not familiar with all of them, and then also a bit on how you can get involved and how you can integrate these practices. So how have things changed? Open science represents, to me, what I see as a paradigm shift. Like all first-year PhD students, we read work by I believe it was Thomas Kuhn on paradigm shifts in science and how these shifts were always quick and dramatic and never very gradual. And I didn't really, I had kind of stopped believing that for a long while because I'd never seen a paradigm shift in psychology. But we have certainly moved into one where we're now moving toward science that is embracing open science practices. When I talk about open science practices, I want to make clear the three specific things that I'm talking about. One, transparency is one big piece of it. That includes access to data, materials, and code to reproduce work. Things such as pre-registration, and I'll talk about all of these in a little bit more detail if you're not familiar. Open access, free access to published articles, free access to the work that you as a tax-paying person have paid for, rather than having it sit behind paywalls. Open source software, freely available tools to conduct work. So now we've kind of freeing up access to the information and the tools for using the information. And some great examples of open source software that have really taken off are R and the Open Science Framework, two incredible tools. All right, the first leg, transparency. Before what we call the replication or reproducibility crisis, psychologists rarely made their data or materials publicly available. And that's really starting to shift. First, we saw journals that were offering open science badges to kind of incentivize the sharing of data. And now what we're seeing is publishing societies, the big publishers, are starting to push on this. The journal I edit is published by Wiley, and Wiley has instituted a policy for all of their journals where there has to be a data availability statement, and they make it very clear that the baseline expectation is that people will share data. Now, that's within reason. We all understand that not all data can be shared, and there's some areas where you wouldn't be able to share data. However, we're now moving toward that being the norm rather than a rarity. Pre-registration. Pre-registration I see as one of the real great advances. Before the reproducibility crisis, psychologists routinely pretended unexpected effects were hypothesized, or they formed hypotheses to fit their data, what's been called harking or hypothesizing after the results are known. This was a common practice, and quite honestly, I was trained to do work that way. You've got the data, and then you created the best story to explain the data, and that was considered normative. That wasn't considered wrong. You were putting the data in its best light. Well, we know that that's now very problematic. To offset this, we've got now the opportunity to pre-register our work. That involves posting a study plan that includes hypotheses and detailed analysis plans before collecting data. Really a great advance. And I'll show you the ins and outs of a pre-registration in a little bit. Registered reports. This is taking pre-registration a step further. Before the crisis, journals would judge research based on how interesting the outcomes were, often disregarding whether it was methodologically sound or well justified. This is why we've got a file drawer problem, why we got a lot of null results that can't get published, because they're not novel, they're not interesting. And I've received a ton of reviews that said, well, these results aren't really novel or interesting, so we're not interested in publishing them, irrespective of the fact that they were well conducted. What registered reports bring in is an opportunity to have your introduction and methods reviewed prior to data collection. And that is really exciting, because what we do with registered reports is once all of that looks good, the intro and the methods, we say, okay, yeah, just go and conduct it faithful to this, and we'll publish it. Very much like what we do with master's theses and dissertations. You have a proposal defense. Once everybody's happy with it, well, it's obvious that you're going to pass your final defense, because we've all agreed on what's going to be done, regardless of what the outcome is. I instituted registered reports at analyses of social issues and public policy, and I'm really enjoying the process. The submissions we get are just great, and two, I think that we're recruiting a better quality of manuscript, because there's a real appeal to having your manuscript basically accepted before you collect data, rather than having to shop it around. You know you've got a guaranteed publication once you finish this. All right, what's up next? Open access. Before the reproducibility crisis, all journals are behind paywalls. If you were at a university, you'd pay about $70 for a single PDF. And that's really horrific, because I can't think of any research study that's worth $70. Well, except all of mine. But so increasingly, we're seeing a focus on open access publishing models, where the science is free to read. A couple of good publications here: Collabora Psychology, PLOS One. Both of those are kind of leading the way in terms of open access. In addition to open access, though, there are other ways that we can make our work freely available. Probably the best way is to publish preprints. Preprints are freely available versions of your submission to a journal. Depending upon the journal, there's different rules. Sometimes the rule is you can only submit the submitted version. Some journals allow you to submit the accepted version. Basically, it's got to be in your Word document rather than their format. But again, this makes stuff more widely available. The Greek symbols you see there, that's for PsyArchive, which is the primary preprint server in psychology. And then finally, we're seeing people taking the matter into their own hands with pirate websites such as Sci-Hub that make anything that's published freely available. All you got to do is plug in the DOI, and up pops the PDF. Oh, sorry, my public service announcement. Please don't use Sci-Hub. All right, we see new societies and organizations popping up. Society for the Improvement of Psychological Science. They hold a conference where researchers get training in aspects of open science. And actually, they have what are called hackathons, where we work on different problems. The PsyArchive is actually a product of that. A product of those sessions. What do we need to be able to do X, Y, and Z? Okay, let's go do them. Really fun thing to be involved with. I was able to go this summer, and I really quite enjoyed it. The Center for Open Science has been a real leader in developing tools for open science and in conducting many studies focused on replication and things of that nature. They've developed the Open Science Framework, which is a one-stop shop for uploading data, materials, making them publicly available. Preprints, pre-registration, all of those things are made easy by the Center for Open Science. Open source software. This has been a really exciting development. We now have a lot of free tools that are available to us that don't cost money. I mean, it used to be if you were just a normal, you'd have to pay like $2,000 for an SPSS license. If you're a student, obviously it's less. But it's expensive, and so is SAS, and so is Stata. However, we've now got a growing body of software that really reduces or eliminates the need for those softwares, and then the commercial multi-level software and structural equation modeling software. None of it's necessary anymore. Jamovi and JASP are graphical interfaces, and of course R is probably the biggest player on this block. What's really wonderful about these programs is they all allow contributions from they all allow outside contributions to improve the program. Within R, there's tens of thousands, maybe they've even cracked 100,000 by this point, of add-in packages to do all kinds of different statistics. If you compare that to the number of people that say SPSS has working to develop new stuff, it's just staggering the amount of contribution you're going to get for R over a commercial program. We've seen the growth of some large-scale collaboratives. The Psych Science Accelerator is a good one. It's a globally distributed network of psych science labs. There's over 500 currently, representing 70 different countries. They coordinate data collection and democratically selected studies. It's a really transparent organization. I'm a member, and every time they're having a meeting, I get an invite. I mean, I'm not on the executive board or anything, but they want to make things open to everybody. I participated in their COVID research study this summer, and it was really minimal work for me. All I had to do was email my IRB a couple of times and get some sort of agreement between our two universities, which was simple. And then I really just had to post their link on our SONA page, and allow our students to get credit for participating. Based on that, I'm going to have my name on 3 publications. That and a little bit of editing, helping out to read the manuscript. But really nothing other than that, and I'm getting 3 publications out of it. It's kind of cool. Another one that I really like is Many Babies. Michael Frank is actually talking on Many Babies, and I would definitely encourage everybody to. Go to take the time to see that. It's a fascinating project. I watched this as it was growing, and I saw Michael making calls to the research community of people who work with babies, saying, "Hey, look, we all know we have a problem with baby research. We just don't have enough damn babies. Each of our labs can't get enough babies to say anything meaningful. We don't have any sort of statistical power to make these to draw these conclusions. However, if we all got together and decided on different studies we wanted to conduct, then we could have the power to say stuff important about babies." Really nice project, nice example of how you can do work with hard to reach populations. And I think that there's a ton of opportunity there for working with other hard to reach populations. And then there's the Collaborative Replication Education Project, or CREP. I want to give a shout out to panel member John Gray. John started CREP. CREP provides resources to help research methods courses run replication studies. Those studies are then eventually combined for publication, giving students some nice real research experience, while also providing a service to the field in providing these replications, high quality replications with lots and lots and lots of data. So kind of the second half of my talk is less about what open science is and more about what you can do, how to get started with it. So one thing I want to say is commit to making your data and materials publicly available if you can. I mean, we all recognize that there are situations where the data just can't be shared, and that is totally cool. Only the most zealoty of the zealots doesn't believe that that there are situations where data shouldn't be shared. We need to end the era of the data available on request statement in papers. You know what? People say it's available on request, but you try going out and doing a meta-analysis and needing that information. These people will just blow you off. I would get routinely responses to maybe 1 out of every 7 requests that I get for information. So data available on request is a sham. Take the time to make your data usable. It will take a little bit of extra time, but you want people to know what your weird variable names actually mean and refer to. Make your code available so everybody can see how you did various things. Maybe do a little annotation to your code if you're doing something weird. Some people, there are a couple arguments I often hear. One is, but I've got other variables in my data set that I want to use. You don't have to post those. We're only asking, when we say make your data available, we mean so that people can independently reproduce your work and find any errors. That's what you need to make available. Take those other variables out. The variables that you already used in their study, you should think of those as being spent. You can't use them again, so why not post them? Nothing lost there. I also hear people say, well, I'd be really embarrassed if somebody found a mistake in your work. And to that, I just have to give the face palm. That's kind of the whole point. My brother-in-law is a software engineer, and when he's not working on proprietary stuff, he says, engineers are always making their stuff publicly available on GitHub so that others can see their work, and it's almost incentivized to try to find errors to make things better. So we really need to change the culture around that. Okay, what's another good thing? Pre-registration is something that you can start making part of your regular practice. This involves clearly outlining hypotheses at every step of data collection, extremely helpful on the back end of your research study. And you've already done this for the most part in your IRB. Let me actually, and bear with me while I change my screen share. Let me go to a sample pre-registration that I have. As many times as I remind myself, I never quite remember to not have 75 windows open when I am presenting. Okay, so here's a registration that I recently did. You can see the information that I need to provide, the hypotheses. So just have them all laid out, the specific design plan, couple of questions here, my data collection procedures. One thing to note here is that I can get a DOI for this. It's time-stamped and it's a permanent persistent identifier. Sample size and then a rationale for the sample size. So really focus on doing a proper power analysis. The stopping rule indicating, okay, when if we go over 350, why would we go over 350? In my case, say, hey, if we start the semester before we have 350, I'm just going to roll until we get to the end of the semester. Just making things very transparent. All of the variables that I'm going to use, of course, a link to my actual questionnaire, how we're going to analyze the data, the inference criteria for exclusions, really important so that we're upfront about where we would be excluding, how we're going to treat missing data, and how we're going to, and what sort of exploratory analyses we're going to conduct. And that's really it. Not a ton of work, but what it is really great for is when I get to the back end here and when the data is collected, I just go to my pre-registration and I'm like, okay, what was I going to do? Well, it's done. I could even, based on the pre-registration, I could even be writing my code before the study and almost immediately have everything analyzed and ready to go. It's really saved me a lot of time taking the hour or two to think this stuff through rather than spending 2 weeks playing around with the data and different models and all kinds of different stuff. All right, so let me go back to my PowerPoint slides. All right, so there are some arguments that I hear against pre-registration, and so I'll go through those. First argument is somebody's going to scoop me. Well, one, I don't think that there's a lot of people out there that are going through and looking for brilliant pre-registrations so they can scoop you. If you pre-registered something, you're already collecting data, so the timing on that is a little off. But also keep in mind that you've got a persistent time-stamped DOI that proves that you put these ideas out there. That seems to me the best argument against getting scooped is because you've got the proof that this is your idea. But I like to do exploratory analyses. Hey, exploratory analyses are great. Pre-registration has no problem with exploratory analyses. Pre-registration wants to avoid having exploratory analyses portrayed as confirmatory analyses when people are harking and doing things of that nature. You can do all the exploratory analyses you want. You just need to be transparent and talk about it. If I make a mistake, I have to redo the whole thing. Well, no, I screwed up pre-registrations and deviated from the plan, and you simply note how you deviated from the plan. I don't think I've done one where I haven't had some deviation from the plan because I didn't realize X, Y, or Z would happen with the data. It's fine. You just need to state it. All right, so what else can you do? Open access and preprints are great for getting your work out there. Many university libraries are now providing funding for open access that's coming out of what they're having to pay for publication fees. Ideally, the goal is that all libraries are going to be able to move to funding open access, because everything will be open access. The European Union has announced something called, I think it's called Plan S. I might have the letter wrong though. Wherein any work produced at a publicly funded university would have to be made available open access. You know, we paid for it, we provided the labor for it, we're not going to pay for it again, so it needs to be provided open access. In the US, there is bipartisan support for a Trump administration mandate on this, and you generally don't hear those words in the same sentence, bipartisan support and Trump Trump endorsement, but it's going to happen in the US soon too. And practically that means every university receives public funding. You could argue that it's not just about getting a grant, it's not just about being at a state school. That public funding is financial aid, and every school has financial aid. So this would be a requirement for every US university eventually as well. In the meantime, if you can't publish open access, if you don't have the funding for it, I certainly do not encourage you to, unless you have lots of money lying around, to pay open access fees on your own. It's about $3,000. If you can't publish open access, make sure to post a preprint. Every journal has to allow you to post your submitted version of your manuscript. The reason being is that you didn't sign over copyright on that submitted version. That's yours. The journal has done nothing to improve that manuscript, so you are free to post that. Some journals allow for the publishing of the accepted version of the manuscript, so long as it's not their journal formatted version. If you're not sure about that, this link here to the Sherpa site will tell you what every journal's policy is, so you don't have to go try to figure it out with each individual journal. Publishing open access and posting preprints really does get a lot more eyes on your work. Every time I post a preprint, even if I don't even tweet about it, I'll see it gets 100 or so downloads. Those are people who wouldn't be seeing this, or certainly wouldn't be seeing it as early. There's a lot of work that shows open access, and stuff that's published in a preprint form also gets a lot more citations. So if you're worried about your H-index, it's a way to give it a bump. What can you do? Learn R. Oh my God. Don't be at the mercy of commercial software. About 5 years ago, I came to my department and I said, look, the way things are trending in data science, if you're talking about statistics, software, nobody's using SPSS. It's not a tool, it's not a skill anymore that people are looking for, yet R is a much more popular skill. And we decided we were going to move all of our classes to R, including the introductory statistics class. Our faculty told me I was crazy and that our students would never be able to learn how to program. And very first day of class, very first lab, I'm looking at my graduate assistant and I are looking at each other in amazement as students are just taking to R like it's no problem. In my graduate student classes, my students love it. We learn a lot. I learn a lot of stuff from them and how deep they go into R and all the cool things that they figure out how to do. I've had students who have now published R packages. Just really has been a real great addition to our training. Oh, and I should also note, this has allowed me to open up to my classes to have far more topical coverage. You couldn't really do multi-level modeling. Well, you can in SPSS, it's just something. You can't do structural equation modeling, confirmatory factor analysis. Can't do a lot of these things in SPSS, but if you've got R, it's all available to you in great packages that are easy to use. So that's been really fantastic. Other things you can do, you can join a collaborative research group. The Science Accelerator and CREP are both accessible and easy to join. They're both very generous with authorship. It really does require very minimal effort. I was on I'm on the COVID, I think I already mentioned this, but I'm on the COVID Science Accelerator study, and I'm going to get authorship on 3 different papers for doing very, very little work. What can you do? This is probably the most challenging one. Take a good hard look at what you teach. Psych textbooks are outdated, especially intro psych. And there has been an arms race in these textbooks to highlight the sexiest research, the most exciting findings. That's problematic because we're finding that a lot of that stuff really rested on a very shaky foundation. If your book still covers stuff like the Stanford Prison Experiment, ego depletion, power poses, just throw it in the garbage. That it's not worth your time, and we shouldn't be teaching students these things anymore. All right, final thing you can do. Open science is largely free. So I think it's important to think about that and to think about giving back a little bit. This can take many forms. You can donate directly to the Center for Open Science. You can do as I'm doing, which is giving time to be a moderator on Psych Archive. What this involves is I give about 20 minutes every Friday to approving submissions, making sure they don't violate copyright, making sure that they are actually psychology. It's not a lot of work. In most cases, I can evaluate something in about 5 to 10 seconds. Some cases it involves a little bit more research, but it's never more than a minute or two. In that, since the accelerator added, the Psych Archive added 70 or 80 new moderators, what's happened is that they've been able to address a backlog of about 8,000 manuscripts. It's not now just about completely wiped out, the backlog, except for stuff that's in languages that we don't have anybody to review. You're going to become a Spark Society mentor. The Spark Society is designed to give a boost to scholars to early career scholars of color. And becoming a mentor is not hard. It just involves doing things like possibly reviewing a manuscript before it's submitted for somebody to help improve their work a little bit, giving it like a pre-journal review. All kinds of easy things that we can do to help raise up others. You can become, as John Gray is, an open science ambassador through the Center for Open Science. But I'm sorry, it's not an ambassador. It's they use a different word, evangelist. And finally, spread the word. Talk about open science in your classes. Integrate open science practices. Make it just normative. Open science is so fantastic for someone like me who teaches statistics. I now can get really great examples from published literature and have students actually working with those data sets. And I've got an assignment in my statistics class where I'm having them search for a preprint on Psych Archive. You can really easily integrate a lot of these things into your classes and help this next generation of students be better open science practitioners. All right, thank you. I hope you enjoy the symposium, everybody.